Imagine just floating effortlessly,
Mm.
lifting off the ground, no noise, no rockets, nothing. Think about cities maybe hovering, safe from earthquakes, or vehicles just gliding silently.
Sounds like pure science fiction, doesn't it?
Exactly, the ultimate dream, really. Anti-gravity. But is it just fantasy? Could we actually engineer something like that, a field to push back against gravity?
That really is the core question, isn't it? And it's
Yeah.
what we're diving into today. We've been looking through some really interesting sources for you. Research notes, bits from a podcast called Sci-Blowing, some key academic papers,
Right.
trying to get to grips with whether engineering something so impossible sounding is even conceivable.
So our mission today is to unpack all of that. What is gravity, fundamentally? Why is it so incredibly hard to, mess with compared to other forces?
And what about the theories? Some are pretty wild.
Uh-huh.
And the experiments people have claimed, what's the deal with those?
Yeah, and what does modern physics say now? Where are we heading? And okay, just suppose it was possible. What would that even look like? What are the implications? The big questions.
Big questions indeed. So let's start right at the beginning. Gravity itself. The sources remind us of something that feels a bit backwards at first.
What's that?
Gravity is actually the weakest of the four fundamental forces. You've got electromagnetism, the strong and weak nuclear forces, and then gravity, way down the list in terms of strength.
It's so weird when you think about it like that, like a tiny fridge magnet. It can hold itself up against the pull of the entire planet Earth.
Exactly. Yet gravity is what holds galaxies together, keeps us stuck to the floor. And the way we understand it now, thanks mainly to Einstein, general relativity, back in 1916,
Yeah.
it's not really a force pulling things.
It's the shape of space-time itself.
Precisely. It's the geometry. Mass and energy, they actually warp or curve the fabric of space-time around them. And what we feel is gravity is just, well, objects trying to travel in the straightest possible line through that curved space. Think of like a bowling ball on a trampoline. It makes a dip.
And if you roll a marble nearby, it curves towards the bowling ball.
That's the idea. The marble's just following the curve created by the ball's mass.
Okay, so gravity is curved space-time. Got it. Now, why does that make anti-gravity so incredibly difficult to engineer? The sources really seem to stress this point.
Yeah, the fundamental problem, as the material lays out, is that gravity, as far as we know, is always attractive. There's no known negative mass.
Negative mass, like stuff that would push instead of pull.
Exactly. Hypothetical stuff that would curve space-time the other way, causing repulsion. With electricity and magnetism, you have positive and negative charges. You can attract, repel, cancel things out.
But with gravity,
Everything seems to have a positive gravitational charge, if you like. Everything pulls on everything else. There's no off switch, no opposite charge we can use to counteract it.
so you can't just build an anti-gravity machine like you'd build an electromagnet. The sources were saying it's more like you'd have to actually rewrite space-time locally, hack the curvature.
That's a great way to put it. You'd need to somehow flatten out that curvature or even bend it the other way without using impossible amounts of, weird energy that physics isn't even sure exists.
Like negative energy density, that kind of thing.
Exactly. Stuff that pops up in some theories but seems, let's say, highly speculative for practical use right now. It's not like just building a stronger engine. It's like trying to change the shape of the road itself as you drive.
Wow. Okay. But that hasn't stopped people thinking about it, right? Theorizing. The material mentions some pretty out there concepts.
Oh, absolutely. The fringes of physics are full of fascinating ideas. We mentioned negative mass, this hypothetical stuff that would fall up.
Mm-hmm.
If you could find that or make it, well, that changes everything.
Game over, right.
Yep.
But probably doesn't exist.
What else? Then there's gravitomagnetism. It's a real effect predicted by general relativity. Just like moving electric charges create magnetism.
Moving masses should create a sort of gravity magnetism.
That's the analogy. It's incredibly weak, but measurable. Experiments like Gravity Probe B detected it around Earth, this tiny frame-dragging effect.
Oh, yeah.
And some theories, mentioned in our sources, have wondered, could you amplify this? Maybe with, say, massive rotating superconductors. Could you generate a strong enough gravitomagnetic field to actually do something useful, like push or pull?
Interesting. And then there's the ultimate space-time hack warp drives.
Ah, the Alcubierre drive. That's
Yeah.
the famous one from Miguel Alcubierre's paper in '94.
The idea is you create a bubble, right? Squeeze space in front, stretch it behind.
Exactly. So the bubble moves potentially faster than light relative to the outside, but inside the bubble, you're not breaking any local speed limits. It's mathematically consistent with general relativity.
But there's always a but.
The but is, again, it seems to require exotic matter, possibly with negative energy density, to create and maintain that bubble. So, elegant idea, maybe physically impossible for us.
Okay. What about zero-point energy? That sounds intriguing.
Right, another avenue the sources touch on, zero-point energy.
Mm.
That's the idea that even empty space, a perfect vacuum, isn't really empty.
Yeah, quantum fluctuations, little particles popping in and out of existence.
That's the one. Quantum field theory suggests empty space has this baseline energy. It could be enormous. So the question raised in the sources is, could we somehow tap into that, manipulate it? Could that influence gravity or provide propulsion?
It's all very theoretical, very much on the edge. But did anyone ever try to, build something, make this happen in a lab? The material mentions some actual attempts or claims.
Yes, moving from pure theory to the lab bench. The most famous claims probably came out of the 1990s. There was the work by Eugene Podkletnov in Russia.
What did he claim?
He reported seeing a small weight reduction, like a gravity shielding effect above a superconducting disk he was spinning really fast.
Whoa! Like things got slightly lighter?
That was the claim, maybe 1 or 2%.
Mm.
And then there was Ning Lai, working in the U.S., in Huntsville.
What was her angle?
She had a theory about rotating ions inside superconductors, generating a detectable gravitoelectric field related to gravitomagnetism, potentially usable for propulsion.
Okay, and NASA even looked into this stuff.
They did. NASA had the Breakthrough Propulsion Physics program. Mark Millis ran it for a while, up to around 2005. They explicitly looked at concepts like these potential zero-point field interactions, other breakthrough ideas. Millis wrote about this.
So spinning superconductors, rotating ions, NASA involvement. Sounds exciting. Did it pan out?
Well, here's the absolutely critical point that comes through loud and clear from all the source material.
Okay.
Despite all the buzz and the debate these claims generated, none of them have ever been independently replicated, not under rigorous, peer-reviewed conditions.
Ah. So interesting results, maybe anomalies, but not proven science.
Exactly. They spurred discussion, which is good, but they don't count as demonstrated anti-gravity. Not by a long shot.
Okay, so we don't have working anti-gravity tech based on those experiments, but does that mean the whole idea is dead in the water? Is research happening now that might sort of touch on this, even indirectly?
Well, the sources suggest that research in related areas is definitely ongoing and could be relevant down the line. Things like advanced materials, science.
Conductors, that kind of
Yeah, especially high-temperature superconductors. We're still discovering weird quantum effects in materials. Understanding how matter interacts with fields at that level, that's fundamental.
What about those gravitational waves we can detect now from black holes crashing together? Does that help?
Detecting them is one thing. Manipulating them is, well, that's a whole different universe of difficulty. But understanding space-time dynamics, how it ripples and bends, that's certainly part of the bigger picture. Maybe more relevant in the shorter term is work on things like the Casimir effect.
Oh, yeah, I've heard of that. That's the thing with two metal plates in a vacuum, right? They get pushed together.
Exactly. Two uncharged plates, very close together. There's a tiny but measurable force pushing them. And the standard explanation involves that zero-point energy again.
How does that work?
The idea is there are more quantum fluctuations, more wavelengths of virtual particles possible outside the plates than squeezed between them. This difference creates a tiny pressure imbalance, pushing them together.
So it's like real evidence for vacuum energy actually doing something.
Precisely. The sources point to Casimir experiments as solid evidence that vacuum energy is real and can exert force. So the question lingers. Could we harness this? Could we manipulate this energy or the effect in a way that interacts with gravity? Some theorists are definitely thinking about it.
Still sounds like a long shot, though.
Oh, absolutely. And the material we looked at is pretty clear that real control over gravity, if it's ever possible, might need a much deeper revolution in physics.
Like a theory of everything.
Something like that. A unified theory. Or a proper quantum theory of gravity. String theory, loop quantum gravity, whatever, finally manages to successfully merge gravity with quantum mechanics. That's probably where the ultimate answers lie, if they exist.
But that's way off in the future, probably.
Very likely. But, as one of the sources put it quite nicely, today's fringe physics may become tomorrow's aerospace engineering. You never know.
I like that. Okay, let's run with that hope for a second. Let's imagine. We crack it. We figure out how to create stable, controllable anti-gravity fields. What happens then? What did the sources say about the applications?
The potential impact is just immense. It changes everything. First off, propulsion. Forget rockets burning tons of fuel just to fight gravity.
It just lift off. Silently.
Right. Space travel becomes radically easier, but think closer to home, too.
Cities.
Yeah.
You mentioned hovering cities.
Imagine. Cities suspended off the ground, no more earthquake damage, immune to floods, vehicles that don't need roads or rails or even wheels, they just glide frictionlessly.
Global transport completely reimagined. No more traffic jams, maybe.
Possibly. Or maybe just hovering traffic jams. But seriously, you could have controlled gravity environments for science labs, maybe even for medicine. How do biological systems react to slightly lower or higher gravity long term? We could find out.
And things like space elevators. They always seem impossible because you need materials stronger than anything.
But if you could actively counteract gravity along the cable, maybe it becomes feasible. It just opens up possibilities we can barely conceive of now.
It's almost too much to process. It feels like it would change the very foundations of civilization. But power like that, it comes with risks, doesn't it? The sources mentioned the ethics, the downsides.
They absolutely did. And it's crucial. This wouldn't just be a new gadget. It's a technology that could reshape global power dynamics overnight.
How so?
Well, think about it. Who controls it? If it's monopolized by one country or one corporation,
Yeah.
it becomes an incredible tool for leverage, for control, even for warfare. Imagine weapons platforms that can hover anywhere, silently.
A tool for global inequality, potentially.
Well, flip side. If it's developed openly, shared responsibly, maybe it leads to an age of abundance. Cheap, clean transport for everyone. Access to space. Resources become less constrained. Maybe it could even foster peace.
Removing some of the reasons nations fight over resources, territory, maybe?
It's possible. The sources suggest the biggest hurdle might not even be the physics or the engineering in the long run.
What then?
Us,
Yeah.
humanity. Are we capable of managing something this transformative responsibly? There was a great quote, "Anti-gravity isn't just about lifting off light. It's about lifting up civilization."
Wow, that really lands. Okay, so let's quickly recap the steam dive. We started with gravity, surprisingly weak, but fundamental. It's space-time curvature.
Right. And hard to fight because it's always attractive, no known negative mass or anti-charge.
We looked at the theoretical edge. Negative mass, gravitomagnetism, warp drives, zero-point energy, all needing physics we don't have yet or stuff that might not exist.
Then the experimental claims, Podkletnov, Ning Li, NASA's program, intriguing but critically none independently verified, still unproven.
We saw how current research, like on the Casimir effect, keeps probing related fundamental questions about vacuum energy, and that real control might need a future theory of quantum gravity.
And finally, the applications. Staggering potential, from transport to cities to medicine, but paired with enormous ethical challenges, managing the power.
It really does put the whole thing in perspective. The science is hard, but maybe the human side is even harder. And thinking about everything we've gone through from the sources, it leaves us with some big questions for you, the listener, to chew on.
Given that no negative mass seems like such a roadblock based on current physics, but also knowing how much we don't know about the universe, do you think something like negative mass could actually be out there, hiding somehow?
And the other big one, if this technology, anti-gravity, if it ever did become real, are we ready? As a global society, are we prepared to handle the risks, to share the benefits, to make sure it actually does lift civilization up instead of creating deeper divides?
Something to think about next time you feel that familiar pull towards the Earth.
Yeah.